Okay, rotations. So there's going to be multiple times within this program where we're going to have to figure out the interior angle of a traverse. We're right now just going to focus on point B. We know from A to B we're going southeast 20 degrees, and from B to C we're going southwest 15 degrees. But the question is, with this information, how can we find the angle of rotation of a traverse? If we have the total station here and their backsides at points A and point C, if I were to rotate my full total station, how much are we going to rotate by? In order to do this, the easiest way to do this is do everything from B's perspective. Pretty sure that's okay. It's kind of hard to spell on iPad. So we go everything from B's perspective. So we want to find from B to A and from B to C. Well, from B to A, we know we're going to go north 20 degrees west, and from B to C, it's actually given to us. We're going south west. Let me make that 5 a little bit nicer. Southwest 15 degrees. So what we can do is translate both of these into an azimuth. Doing rotations in azimuths are the easiest way to do things. For me at least. You may find it a little bit challenging, a little bit different. So 20 degrees northwest as an azimuth. Let's see what that will be using this hourglass rule that I've brought up multiple times. Looking at this, we can say we're in the northwest quadrant based off of B to A. So we have to say, in order to obtain the azimuth, 360 minus 20. We know we're going to get 340. You could put it in the calculator if you need to, but some mental math is just quicker. Okay, from B to C, it's southwest 15 degrees. Southwest section, in order to calculate an azimuth, we say 180 plus a bearing value, 15, we get 195 as our azimuth value from B to C. So now we have to figure out what is the angle of rotation from this line of B to A to B to C. We essentially need to find the difference of 340 minus 125. So 340 minus, I'm sorry, did I say 125? I should have said 195. 340 minus 195. If you want, we can just pop this into a calculator real quick. 340 minus 195. You have 145 as your value. So that tells me this interior angle of this polygon is 145 degrees. If for some reason I needed the exterior angle from here, I could just say 360 minus 145 and get the remainder of that value, which is 215. So we know our exterior angle will be 215 degrees. 215 plus 145, we get 360, which is a full rotation, which is essentially a circle. And you can do that with any angle or any point. You just always want to do it from your point's perspective to find your interior and exterior angles. We notice 145 is the interior because it's inside this polygon, this traverse that's closed. The 215 is the exterior because it's on the outside of the polygon, or the traverse that we ran.